Okay, then let's start with this mass. How you pronounce it? Mass or mass?
Mass, whatever.
Yes, we always have studied this, pronounce it like mass, but nowadays it's like mass.
Yeah.
Okay, what's the difference between mass and weight?
Can I tell what it is? No,
But
like weight depends on like.
today I prepared myself to start Kepler's law of planetary motion. I prepared myself.
Ma'am, can I tell the difference between mass and weight?
Difference between mass and weight. Yes, of course.
Weight is like how will I describe it? Like weight is like it has something to do with the gravitational force. So let's say like if this pen was here on Earth, it would weigh some amount of, but if it some amount of grams. But if it went to like if the pen went to Jupiter or something, then also then since the gravitational force is more, so if it could like be there, then it would be more than like the Earth. Or if it was on Mercury, then it would be way less. But if it's talking about mass is fixed where like wherever you go. If you go to Jupiter, your mass will be same. But if you go to Mercury, your mass will be the same. Anywhere in the universe, it doesn't have like it's irrespective of position.
Gravitation. It's irrespective of gravitation. Hello. So, Razi, I wanted to ask you that why didn't you done that? Did the test paper? Write the test paper of
Ma'am,
LOM.
because my monthly tests were going on, and the next day it was my SSC test, ma'am, and there are two subjects, political science and geography, so I have to study
Is it
the
exams?
maths.
Is it exams going on?
No, my monthly test, ma'am, which are of 20 marks.
Okay, and one more thing that you have to let me know, that is the Kepler's law of planetary motion coming in your first term?
Ma'am, I don't remember, but my teacher hasn't taught it yet.
You don't know your exams is going to come. You must be knowing this.
Ma'am, I knew, but I forgot the syllabus. Ma'am, I know the syllabus of maths and everything, but I forgot.
You forgot.
Physics and chemistry.
Okay, then you have to check it, because I have to start. I had to start with the planetary motion, but in Shazan it will not come. In Shazan first term it will not come. So I uh, just now have started maths, that because maths is coming. And what about you? If it's coming in your exam, then I will start that planetary motion.
Okay, ma'am, I will check and just text you.
Okay, then let's start with mass. Then I will be doing, if it will be coming planetary motion, then Kepler's law of motion, then I will do it in the next class, or otherwise we'll do the revision work from MIL to gravitation. Okay.
Okay, ma'am.
Okay. So mass and weight. First of all, I want to know about the difference between gravity and gravitation. Gravity and gravitation. Gravity and gravitation. Tell me, Shazan, Razi, Arham. Razi, can you please switch on your camera?
Okay, ma'am.
Okay. Tell me the difference between gravity and gravitation.
I don't know.
We have to complete this mass and weight anyhow today. Okay. There are some examples. Okay, tell me. By the time, tell me.
I don't know.
You don't know. Gravity, it's just one sentence answer. That gravity, we use this word especially for Earth. We use this word for Earth only. Gravity. Okay. Gravitation for the whole universe. Anywhere in the Jupiter, in the Mars. What gravity?
But I've heard gravity been using for the moon and Mars. Like moon, Mars,
I'm telling you, no. This is why I'm telling you. We use gravity like moon का gravity Earth से 1/6 होता है. This is what we talk like, right? Yes. This is how we talk like. But we don't need to say that gravity for moon. No. Not anything, not any other planet or anything, anything in the universe other than Earth. Only we use this gravity word for Earth. Okay, not for any other, object in the whole universe. And for the rest, we use gravitation for the all objects. For all the objects, because everything has gravity, right? Everything has gravitation, right? Everything is gravitation. So we can write it like for all the object in the universe.
Same, it's constant for all the objects.
Yes?
Same and constant for all the objects in the universe.
I didn't get you.
I remember that universal law of gravitation that my big tree was there.
Law of gravitation.
Ma'am, it is same throughout the universe.
Universal law of gravitation is for whole, no?
And for even for atoms also.
Yes, universal law of gravitation. The law of gravitation works for every particle in the whole universe. Every particle in the whole universe. Okay, we use it for everything. Even the dust particles in the air. Even the dust particles in the air has what? Gravitation, right? But it doesn't work because it's so small. Because it's so small, right? Because their masses are very small. M1 and M2 are very small.
Ma'am, you take like, but if you had like, it's like everything has gravity, but also like if you kept like
Everything is gravity.
like 1 kg balls in space,
Hmm.
1 kg balls in space, I think in space like 1 meter apart, it'll take maybe like 2 weeks to collide.
Have you read anywhere this thing?
Yes. And if you take a tennis ball, it'll take like 2 to 3 days, maybe. I don't.
Okay. Okay. We'll talk about it later. Okay. First, we need to talk to the point. Okay, because we are having half an hour and we have to complete this topic in here. Mass and weight. What is the difference between mass and weight? As Arham told, that weight is related with gravitation. Something has to do with gravitation, with G, with G, and this mass has no relation with G, and it's constant for everywhere. Mass doesn't change of any body, of any of the body in the whole universe. It doesn't change for in anywhere, no matter where it's kept, even in the Jupiter, even in the Mars, even in the Sun, or on the Earth. Okay, so wherever it is kept, the mass will be the same. It will be constant throughout the universe. So weight has to do with the G. It has to do with with this
Gravitational constant
and this G gravitational constant. This G is different
on different planets.
for different planets, and even on Earth or itself. Even on Earth itself, somewhere it's 9.8 meter per second square, and somewhere it's
like 9 meters per second. Sometimes it's 10 meters per second
square. Okay, so it's weight is what? Weight is normally it's the force that is applied on the Earth. It's just the force. Force is what? Force we have already read in the last chapter. If it's
equal to mA.
So weight is what? Weight is mg. G is what? Acceleration due to gravity, right? G is acceleration due to gravity, and m is mass. M is same, and a is also same because a is what? Acceleration meter per second square, and g is also acceleration meter per second square. The only difference is that G will be constant, right? G will be constant. So in one place on Earth, or if we talk about moon, whatever be it is, the G will be constant. So it's weight. Weight is what? Weight is just a force. It's just a force. Okay, and mass is it's the content that is contained in a body. It's the content, total content of the body. Okay, total content of the body means the whole content that is the body is made up of. Okay, and you tell me that what is the thing that measures the inertia of a body? Tell me.
How?
What is the thing that measures the inertia of a body? Inertia of a body is dependent on what?
Acceleration.
Mass.
Oh, sorry.
Mass and acceleration.
More will be the inertia. More will be the inertia, and less will be the mass. Less will be the inertia. Okay. It is a scalar quantity. Scalar quantity होता है, and its SI unit is kilogram. SI unit is kilogram. In other words, mass is the quantity of matter contained in your body. Okay. The matter, how much matter is contained in a particular body. That is called mass. Okay. It's a scalar quantity, and it always remains constant everywhere. Irrespective of the position of the body in the universe, mass always remains constant everywhere. The mass of the body cannot be zero. It cannot be zero, even if the dust particle of the air. It definitely be having some mass. It may be very less that we cannot see even from our naked eye, but it will be having some mass, right? So mass can never be zero. Mass can never be zero. Okay? Yes, Shazan?
Ma'am, light is there, ma'am. Ma'am, the mass of light is zero. Why?
Mass of light is zero.
Yes.
Light has two characteristics. Light has two nature. Do you know of that?
No, ma'am.
Light has some particle nature.
Weird stuff.
Light has two natures.
And this is like particle and wave, right?
And wave nature. So if we talk about particle nature, then it must be having like alpha, beta. These are the rays also, right? These are the things that are coming from the sun. And there are some of the particles also. Like right now, I am not like I couldn't I'm not able to remind, but there are particles that is due to which we call light acting as a particle nature. So, but if we talk about those particles will be also having some mass. If we talk about those particles, then those particles will be also having some mass, but it will be too less. It will be too less, right? Very,
This mean?
means it will be very small mass,
Okay.
very light. Okay, that it we can consider it as negligible.
Okay, I thought you said two less, like two less.
No, less. Okay.
Got it.
Weight of an object is the force with which it is attracted towards the earth. Okay. Weight is what force. This is what I told here. That weight is exactly that we can say in other words a kind of force. Okay. And we already are knowing that force is equal to G by R square. We already are knowing that we studied in the first topic. Okay, GMM by R square, or we can say like GM1 M2 by R square. Okay, R is the distance between the two bodies and distance from the center, especially distance from the center. F is equal to GMM by R square, GM1 M2 by R square, whatever it is. So in place of F, we can write W here, right? In place of F, because F is same as W. W is what? F, force. So we can write in place of F, W. So this can be the formula for weight. Mass of the earth, where M is the mass of the earth and R is the radius. So important points regarding weight as follows. So what are the important points? Weight is a vector quantity, right? Because it is dependent on acceleration, and acceleration is a vector quantity, right? Acceleration is a vector quantity. Weight is equal to mg. G is the acceleration. It is a vector quantity. So it will be what? It will be what? Vector quantity. Okay, fine. So weight is a vector quantity. Obviously, force is also a vector quantity. Even velocity is a vector quantity. But mass is a scalar quantity. Okay, mass is a scalar quantity. Vector quantity, it acts vertically downward direction. Yes, it's act when we talk about weight. Now the only difference in weight and force is what, that especially that for weight, it's act, the direction of weight is what, in downward direction. Because whenever we talk about weight, we consider this that we are comparing this from earth, this by the earth. Because when we talk about weight, then we say that yes, this man is standing on earth, and this man is not this girl, this is a girl. So this girl is standing on this earth, and she is and she is having weight something. So it cannot be like you are standing on earth and you are taking your you are taking your reading of weight, taking a reading of weight in respect to the other particle, respect to the other girl is standing beside her. So it's not like that. You are not going to compare it with other particle or other object. You are going to take the reading of your weight through standing on earth only. So the direction of the weight will be always downward direction. Okay, it will be always downward direction.
Towards the center of mass of the earth.
Yes, towards the center of the mass of the earth. And its SI unit is Newton, same as force. Okay.
Force.
Weight of 1 Newton of weight of 1 kg mass is 9.8 Newton. Why? Weight of 1, if we wish to know about the mass of 1 kg, so what it will be? We are knowing about the G, that is 9.8 meter per second square. So we can easily find mg. We can easily find weight, that will be 9.8 Newton. Why? Because 9.8 into 1, this is 1, this is 9.8. And if we are going to multiply this, then we will be getting 9.8 Newton. Okay, 9.8 Newton. So weight of 1 kg, weight of 1 kg mass on earth, what it will be? It will be 9.8. And you tell me one thing that we always, that means almost everyone is confused. In weighing machine, what we actually take the reading of?
No.
First you tell me what you call to the weighing machine. Weighting machine, because many of the persons say it's like weight machine, weighting machine.
Weighing machine.
What do you call this? Weighting
machine. Not waiting machine, weighing machine.
Shazan, what do you call this?
Ma'am,
Weighting machine or
yeah,
weighing? What?
Going forward.
What do you is
What do you call a weighing machine?
Yeah, that only, the weighing machine.
weighing machine?
Yeah.
Okay, Rati, what do you call this?
Weighing machine.
Weighing machine. So, do you weigh your weight or do you weight your weight?
Yeah.
Do you weigh your weight or your mass? Because normally
We actually weigh our newtons. How much force is applying up.
or do you weight your weight?
Ma'am, in weighing scale we measure our newtons.
In weighing machine?
We measure newtons. Sorry,
No.
not newtons, like normal force. Sorry, normal force.
No, I'm saying, what do you say? I'm going to weigh my mass or weight my mass?
Most like
करने जा रहे
we
हैं.
use I am gonna weigh my mass, but yeah, most people say that. But it should be I am going to weigh my weight.
But actually, it's mass. So okay, do you say weigh or weight? Weigh is a verb, right?
Weigh my weight.
You have to say that I'm going to weigh my mass, right? Not weight. Weight करने जा रहे हैं नहीं. Weigh करने जा रहे हैं. Okay, it's not weight. It's not weight. It's what? Weight. This is your weight, which is a noun. Okay, and when you are going to weigh, then that is called weigh is a verb. Okay, so never get confused with this that weight करने जा रहे हैं. So no, never say this. This you have to say that weigh करने जा रहे हैं. Okay. And not this rasta wala way, naapne wala way. Okay. And from the weighing machine, what we get? Our mass or weight?
We get the normal force.
And Shazan, what? Can you see the unit that is written over the weighing machine? What's that?
It says kg, but we actually measure it in newtons and then we convert it into kgs. What we take is how much newtons it is, and then we are dividing it by the gravitational force, and you'll get kg.
And what do you think, Shazan?
Remember, it says mass PFA.
What do you get from weighing machine? Your mass or your weight?
Then we get our mass.
Get our mass. Okay. And
Yes, we get our newtons.
what do you think?
That's only mass.
Weight, right?
Yes.
That's weight, right, ma'am? It's weight.
Weight. Weight. Weight resistance.
That one.
You got to know about weight from the weighing machine. You're saying this.
No, but I'm thinking about like normal force.
Weight. Do you see that what's written on the kg or force? Kg or newton? What's written in the weighing machine?
kg.
kg ना तो हम लोग मास नापते हैं, right? लेकिन mass कैसे नापते होंगे? देखो.
I don't think we do mass.
We got to know about our mass.
But if I push a wall while weighing while standing on a weighing machine, it goes up.
Goes up. What goes up?
Yeah, the weight goes up.
What goes up?
The
Where?
weight on the weighing machine.
Weight
If I go on an elevator with a weighing machine, and actually one time I did it, like when it was accelerating, the weight was changing, but mass obviously can't be changing, right? So
this we need not to be. It's not need to be discussed here. That in the elevator, when ऊपर जा रहे हैं तो mass क्या होता है, नीचे जा रहे हैं तो mass क्या होता है. So we need not to discuss it here. Okay. Right now you are on Earth. Okay. Not on elevator.
Okay, then it's most likely mass.
तो इसमें हम लोग को मिलता है मास. एक्चुअली में वेट ये क्या करता है, मेजर करता है. ओके, एक्चुअली ये वेट मेजर करता है, बट इट्स ऑलरेडी डिवाइड हो जाता है वो किससे,
divided by the
okay. So whatever be the 9.8 or you can say 10 say divide हो जाता है, and then we get what our
we get our mass.
25 kg, whatever it be. So if we talk about our weight, then we have to again multiply it by 10 so that we can get the force that we are applying on Earth. Our weight. Okay.
Or 9.8.
What we get from weighing machine, we get mass. Okay. ये ऑलरेडी उसमें रहता है कि वो अपॉन 10 हो जाएगा या अपॉन 9.8 हो जाएगा. सो अब यहाँ पे क्या है, it's comparing mass of weight of the object on moon by weight of the object on Earth. Okay. Now we'll see how. See, you can take it. See, it's placing the values of mass, mass of the moon, mass of the earth, radius of the moon, and radius of the earth. Okay, radius of the moon and radius of the earth. So here, what we have to write, that let a mass of object m be placed on the moon, and the same object we will place it on earth. Okay, same object we'll place it on earth. So I'm not writing it per se. So we will do it in this only, because already because we have to finish it also. So we are comparing. To compare the two quantities, what we do, we divide weight of the object that is on the moon and weight of the object that is on the earth. Okay, this is what force is now. For force we can write it weight, right? The same thing we can write even. This is also force, so we can write, because we are taking here for weight, so we can write weight. So weight of the object on moon and weight of the object on earth. So what will be the weight of the object on moon? Where will G M M? M means this, M and M means mass of the moon. Okay, and M and E means mass of earth. Okay, so M into M. So M into M is what? Mass, right? Mass into mass of the moon or the earth, whatever you say, and into the mass of the object. So mass of the object, M1 into, right? M1, M2. This is what it is, right? So M1 is the mass of the moon, and M2 is the mass of the M here, which is the mass of the object. Upon Rm square means radius of the moon chi square. Okay, upon, because we have written here Wm by We. Now we have to write for We. Okay, Me. Now it will be Me, because mass of the earth we have to write, and M will be the same because the same object is placed on earth. Okay, now what will be the radius of the earth square? Okay, radius of the earth square. Then see, these two quantities can get cancelled. Yes, M, G, G. Can these two get cancelled? These are in division, right? This is a numerator, and if we take it out here, so it will come in the denominator. Okay,
Yes,
so it will become, they both will get cancelled. Now what will be left with? We left with Me by Rm square. Sorry, Re square will go to its numerator. So Re square first, and then Rm square. This is what we have got. Now we'll put the values. Okay, so what will be the values? What are the values? Values are already given. 5 mm, Rm, Me, and Re. So these four of the values we will put in this equation to get the relation between Wn by We, Wm and We. And after calculation, we will get Wm by We is equal to 1 by 6. We will get this. It means that We is equal to 6 Wm. Means whatever be the weight we'll get on the earth of an object, of any object, if we'll multiply it by 6 times, sorry. Whatever weight we will be getting of any object kept on moon, if we'll multiply it by 6, then we'll get the value of the weight that if the object would have kept on earth. Okay, means the weight on earth of an object is 6 times the weight of the same object on moon. Okay, means the gravitation constant, what we call that, the G is 6 times larger than the 6 times than that of the weight on the gravity on the moon. Okay, the G of moon is, gravitation of moon is 1 by 6 of the earth. G of moon, 1 by 6 of the earth. Now we have some questions here, so we'll see. Mass of an object is 12 kg. Okay, we are given mass 12 kg. Calculate its weight on the earth. Okay, weight on the earth. So what it will be? Weight on the earth means mg. So it has talked about earth. So for G, we will take what? 9.8. 12 into 9.8. Whatever we will be getting, like it's 117.6 Newton. Okay, this will get fine. Now weight on the moon. Just now we have got a relation between weight of the moon will be what? 1 by 6 of the weight of the earth. Right? This is what we have got, the relation between weight of the moon and weight of the weight of the object on moon and weight of the object on earth, right? And then what we'll get, weight of the object on earth, we already are knowing that 117.6 by 6. Whatever we'll be getting, that will be weight. Okay, this will be weight of the object on moon. This we'll be getting as answer. Okay, now the second question, next question. A man weighs 600 Newton on earth. Okay, this is the weight that we are given. What is his mass if G is this? Okay, W is equal to mg. G is given. Okay, mass we have to find. So mass will be what? W by G. Yes or no? Shazan, are you there?
Yes, ma'am.
Okay, I cannot see you, so I asked.
Oh.
So weight is what? 600 upon G is 10. So its mass will be, the object mass will be, the mass of the man will be what? 60 kg. Okay. Okay. On the moon, his weight would be 100 Newton. Obviously, on the moon, it will be 100 Newton, right? क्योंकि यहाँ पे Earth में 600 है, तो upon 6, it will be 100 Newton. What is the acceleration due to gravity on moon? What will be the acceleration due to gravity? Now we already have known about the mass. Okay, that is 60 kg. And one more thing that we have got known is about the weight of the object on moon, that is 100 Newton. So can we draw the G of moon? What it will be? W upon M. Would it be this or not? W is equal to mg. So G is equal to W by M. Yes or no? Yes or no? Yes or no?
Yes, ma'am. Yes, ma'am.
So what will be the answer? What will be the gravitation? 5 and 3. So we'll get 1.67 around, right? Yes or no? 1.67 around, no?
It's the 1.67.
Yes, ma'am. Yes, ma'am.
Right? So meter per second square. This will be the gravitation. This will be the what? Acceleration due to gravity. Okay? What will be the acceleration due to gravity? So it will be 1.66 meter per second square. So we can write it like 1.67 because 666 will be going on and on and on. The particle weighs 120 Newton on the surface of the earth. सारा क्वेश्चन हम ही कर दे रहे हैं. गलत बात है. At what height above the earth's surface will its weight be 30 Newton?
Yes.
Will you do this? I don't think that you can do this. Don't think. Do you think that you can do this?
No.
No, ma'am. Okay. Particle weighs. See here, weight not weighs. Okay, because W is weigh is a verb. Okay, science is also English में पढ़ते रहा करो. A particle weighs 120 Newton. जितना information सब gather करते रहा करो. Okay. Particle weighs 120 Newton on the surface of the earth. Okay, fine. That we have known about the weight. We have known this weight. At what height above the earth's surface will its weight be 30 Newton? कितने height पर इसकी weight जो होगी वो 30 Newton होगी. It's asking about this. Weight of the particle at height h above the earth's surface. जो कि वो क्या रहेगी? 30 Newton. Okay. हमको क्या निकालना है? Height निकालना है. Radius of the earth is this. So we have got the radius of the earth as 6400 kilometer. 6400 kilometer. The weight of the particle on the earth, on the surface of the earth is, the weight of the particle on the surface of the earth is, weight of the particle, so the weight of the particle on the surface of the earth will be what? It will be how much? mg. Weight क्या रहेगा? mg तो रहेगा ना surface of the earth पे, right? mg. And if we will write the value for g, that because we haven't studied about the Kepler's law of planetary motion ना, उसी के बाद ये g की वैल्यू डिराइव किया था, जो कि होगा gm/r². ठीक है, अभी के लिए देख लो, ये चीज याद कर लो कि इसकी वैल्यू क्या होती है, g की gm/r². ठीक है. न्यूटन जो है ना, वो थर्ड लॉ ऑफ प्लैनेटरी मोशन को, केप्लर्स थर्ड लॉ ऑफ प्लैनेटरी मोशन को यूज किए थे कि किस तरीके से जो जी होता है वो r² पे डिपेंड करता है. ठीक है, वो ये देखे थे. तो देखो ये क्या होता है, ये फॉर्मूला डिराइव किए थे gm/r². g is equal to gm/r². सो यही वैल्यू हमें किसमें रख देनी है? इसमें रख देनी है. mg/r². gm/r² और mg/r², it will be same, right? So mg/r². This is what we have got now. gmm/r². W is equal to, we can write it directly also, gmm/r². This is what it is. gmm/r², right? This is what it is now. So we need not to mention all these things. So W is equal to gmm/r².
Right, I did.
So W1 will be the weight of the particle at height h above the earth's surface. हम लोग W1 ले लिए हैं weight of the particle को. Okay, weight of the particle at the height h, जो कि height h पर above the earth's surface. So if we write simply W, then what it will be?
gm/r².
gm/r². And for this W1, it will be, because it will be at height h from the ground, so it will be, we'll just add this h in on earth. Okay, So what will be left with? MM cancel, right? MM cancel and MM cancel.
R plus H square, ma'am, will be the reciprocal circuit. R plus H divided by R.
So by R square. Now substituting these values we get what? How to substitute these values? See, we are having these two things also. 120 Newton and 30 Newton. W and W1. What we are going to do this? W and W1. We are going to substitute these values in W and W1. Okay, 120 and 30 Newton. So you will do these 3 questions again. Okay, and send it to me. Okay, send it in the group. Okay, 120 by 30, because I will send the PDF of this, so you can refer the answer. R plus H by R whole square. Can we write it like R plus H by R whole square? Can we write it like this? Because R plus H is whole square and R also square. So can we write it like this? A square by B square को हम लोग ये लिख सकते हैं ना, A by B का whole square, है ना? So R plus H by L whole square. So what we are going to get here, 4 is equal to, we have ये बस दोनों को कैंसिल कर दिया, 4 कर दिया, ये 4 हो गया, R plus H I square. Okay, now taking square root both side, अगर स्क्वायर रूट ले लेंगे हम बोथ साइड, तो ये इसका स्क्वायर हट जाएगा और ये किसमें आ जाएगा, ये 2 हो जाएगा, बन जाएगा, बनेगा कि नहीं बनेगा रसी? बनेगा ना? तो 2 is equal to R plus H by R. Will it be this or not?
इसमें will be that.
See, अभी जादू दिखेगा तुम लोगों को, जादू बहुत मजेदार. 2R ये हो गया, देखो इसको यहाँ लेके गए R को, या taking this R to LHS, तो ये 2R हो गया. 2R को जब हम यहाँ पर लेकर के आए, ये वाले R को, क्योंकि यहाँ पे R plus H था, तो R को जब हम लेकर आए, R is equal to H मिल गया हमको, जादू नहीं हुआ. R is equal to H. The radius, whatever be the radius of the earth is, we will not consider the height at which the object is kept from the earth. कितने हाइट पे रखा हमको ये नहीं देखना है, हमको सिर्फ और सिर्फ रेडियस ही अर्थ का इतना बड़ा है कि हाइट का कोई वैल्यू ही नहीं है. अब तुम बताओ, तुम समुद्र में डालोगे 1 बाल्टी पानी तो कुछ फर्क पड़ेगा? कुछ फर्क पड़ेगा समुद्र पे? नहीं पड़ेगा ना. तो तुम रेडियस ऑफ अर्थ है, रेडियस ऑफ अर्थ, अब तुम इसमें इतनी हाइट बढ़ा दो, या चलो 1 तल्ला हाइट बढ़ा दो, ठीक है, 1 फ्लोर हाइट बढ़ा दो, कोई फर्क पड़ेगा? कोई फर्क नहीं पड़ेगा. वो क्या कर लेगा 1 फ्लोर हाइट, है ना? अब तुम escape velocity से उसको बाहर तो नहीं भेज दोगे कि 9.8 किलोमीटर पर सेकंड से, सॉरी 11.2 मीटर पर सेकंड से, किलोमीटर पर सेकंड से भेज दो उसको बाहर, तो तब तो भाई ग्रेविटेशन काम ही नहीं करेगा, है ना? तो तुम्हें क्या करना है, अगर तुम 10 किलोमीटर पे भी रख दो तो भी क्या करेगा, 10 किलोमीटर पे भी रख दो तो भी उस हाइट की कोई वैल्यू नहीं है. 6400 किलोमीटर की जगह, है ना, आपके सामने कोई वैल्यू नहीं है, ठीक है. तो इसीलिए R इज इक्वल टू H कह रहा है. यहाँ पर H की कोई वैल्यू ही नहीं है जो ये कह रहा है, ये H की कोई वैल्यू ही नहीं है. ये R लिखो या R प्लस H करो, कोई फर्क नहीं पड़ेगा, वैल्यू वही आनी है. तो हाइट ऑफ द पार्टिकल विल बी व्हाट? Radius of the earth. So height of the particle will always consider it as the radius of the earth. Okay, Shazan got it? So if it's written कि इतने हाइट पर है, तो क्या उसका वो फोर्स चेंज हो जाएगा? तो no, the force will not get changed. The same force will be acting on that object. Okay, fine. तो बहुत गंदा कर दिया, हम इसको हटा दे रहे हैं ताकि तुम लोग समझ सको, नहीं तो ये इतना गंदा रहेगा तो कैसे समझ पाओगे पीडीएफ, ठीक है ना? समझ में आ रहा है ना? सब आ गया समझ में? ऐसा तो नहीं कुछ नहीं आया? क्या बोल दी?
आया, समझ में आया.
समझ में आया ना?
हाँ.
ठीक है, तो we can close it for today and one ये मास कंप्लीट हो गया. और हाँ रजी you will be telling कि कोई केप्लर्स लॉ और आ रहा है या नहीं. ओके, अभी चेक करके मुझे अभी बता दो, ठीक है? अभी मैसेज कर दो.
When will you answer sheets for the alarm?
हाँ हम हमें रिव्यू बस कर लेने दो, क्या पता तुम्हारा
It's there in drive, right, ma'am?
क्या पता तुम्हारा मार्क्स कट जाए. हम तो नंबर काटते हैं ना ज्यादा, अगर हमें पेपर दिया जाए तो हम तो नंबर बहुत काटते हैं, इसलिए हमें नंबर पेपर नहीं दिया. रियल मार्किंग में नहीं आती करने. चलो ठीक है, कर लेंगे तो फिर कॉपी में भेज देंगे, ठीक है?
Ma'am, is it there on drive?
Drive, yes, it must be there on drive, on that submission folder. Okay, and
Just go check it.
अगर रसी नहीं होगा Kepler's law, then we will be start from MIL. Okay,
Okay, ma'am.
okay.